So first of all, I want to recognize our Spotlight student for level M, Ryan Joe. Is Ryan here?
Yes.
Hey Ryan, can you introduce yourself? Apparently I already said which grade and your name, but just say it again and tell us your favorite things about math.
I'm Ryan Joe. I'm in the 6th grade at J.M. Robbins Middle School. My favorite thing about math is that I have to learn new things, because some other subjects I feel like it's kind of boring and it's repetitive, but I always learn new things in math.
Cool, very good. All right, so you are the Spotlight student today. I'm going to give you problem number 3. Okay, so you'll be talking about problem number 3. There is actually a runner-up in this. 2 students getting all 3 questions correctly. Actually, there are 3, but one of them had some help from the parent. So just a reminder, before you submit answers, don't get help from the parents. So just think through. If you can, just leave empty. That's okay. But you can leave how many minutes it take you to get an empty solution. That's okay. But I'd like you to think about the problem over and over. It's okay if you don't get the answer, as I said. So, but don't get help, right? So after submitting the answer, you can ask help if you want to, right? There was a runner-up. The runner-up is Raghav. Is Raghav here?
Yes.
All right, so you're the runner-up. I'm going to give you one of the other 2 problems. So which one do you prefer?
I will take number 2. I'll take number 2.
Number 2. Okay, cool. So that's a more difficult. Cool. That's a more difficult one. Please mute yourself. Everyone, please mute yourself, and then let's get started. I will talk about problem number 1. Okay. So problem number 1. Well, I cannot calculate. I cannot copy this equation to the notepad. But let's first read it here. Problem number 1. I ask you to calculate this fraction. So this fraction, on the top, there are 2 square plus 4 square all the way to 100 square. So you can see it's a summation of even numbers, squares of even numbers, right? And then it's minus what? 1 square plus 3 square plus all the way to 99 square. So this is a summation of odd numbers. And then in the bottom, we have 1 plus 2 plus 3 all the way add up to 10. And then going to 9 plus 8 all the way back to 1. So from 1 to 10 and then back to 1. So it look like, looking at this problem. So when I look at this, well, there are 2 squares, 4 squares. Apparently, I'm not going to calculate the summation of those squares. And I'm not going to calculate the 1 square, 3 square to 99 squares either. But one way I can do this is to rearrange them, right? So if I rearrange them, I do 2 square minus 1 square. And I do 4 square minus 3 square. And then all the way until 100 square minus 99 square. Then there will be something interesting happening, okay? So let me show you what I mean. So if I can do 2 square minus 1 square, right? And do 4 square minus 4 square minus 3 square, and 6 square minus 5 square, all the way down to 100 square minus 99 square. And this gave us something nice, okay? Of course, at the end, we need to add them up, right? Add up. That will be the answer for the top part of the fraction, right? So let's see what we got here. Apparently, when we minus these squares, let's say 6 square minus 5 square, right? 6 square minus 5 square. One way to do this is to 6 square is 36, 5 square is 25, 36 minus 25 is 11. I mean, this is okay for a smaller number. How about 100 square minus 99 square? I mean, this is 10,000 minus 9,801. This is tough. 199. This is tough, right? Can't do this for all 50 pairs. There are totally like 50 of them. So, but we know that if we have two numbers, a squared minus b squared, we can write them into a plus b times a minus b, right? So this is the nice feature of the subtraction of squares. So why do we get this? Just look at this. A plus b times a minus b, a plus b times a, that will be a squared plus ba minus b. So plus a minus b plus b minus b, right? So ba and a times minus b, they canceled. So this equal to a squared minus b squared, right? So we know this feature, right? So a plus b times a minus b. So what we got here is 2 squared minus 1 squared is 2 plus 1 times 2 minus 1. 4 squared minus 3 squared, 4 plus 3 times 4 minus 3. And 6 plus 5 times 6 minus 5. All the way down to 100 plus 99 times 100 minus 99. What's nice is 2 minus 1 is 1. 4 minus 3 is 1. 6 minus 5 is 1. 100 minus 99 is 1. All these are 1, so we can just get rid of them, right? So then this summation becomes 1 plus 2 plus 3 plus 4 all the way plus 100. So this is 1 plus 2 plus 3 plus 4 plus da 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 plus 100, right? We know how to calculate this. Right? So these are 50 pair of, if you do, 1 plus 100 is 101. 2 plus 99 is 101. In total, there are 50 101s. So this is 50, 50, right? So we figure out half of this fraction. The top half is 50, 50, right? The bottom half is 1 plus 2 plus all the way to 9 plus 10 plus all the way to 9, 8 plus all the way to 1, right? So the bottom half is easy to calculate as well, right? So we can just add them up. You can do manual addition. That's a slower way to do this. But look at these. We can make them pairs as well, right? So there's 1, there's 9, so that's a 10, right? There will be a 2 here, 2 and 8, that's a 10. And all the way to here, 1 and 9 is a 10, right? So there are 9 tens plus there's a 10 here. This is 100. So what we got is 50, 50 divided by 100. So that's 505 divided by 10, right? So that's 50.5. That's the answer for the first question, 50.5. Okay. Well, I don't know if there are other ways to do this. Any other comments on this? Okay, so I'm seeing Akash. Okay, good. So Akash, you're saying, why don't you unmute yourself and then talk about your method?
Oh, I was just like thinking about like I just wanted to tell like the formula times like n, which is n times n plus 1 divided by 2 plus n times n minus 1 divided by 2 equals n squared, because
Go ahead. So are you saying the last one, 1 plus 2 all the way plus 9 plus 10, and then to plus 9 plus 1, this is 10 squared? Is this what you're saying?
yes.
All right. So well, part of it is you're using the arithmetic sequence. So basically, if you look at 1 all the way to 9, this is 1 plus 9 times 9 divided by 2, right? Is this what you're trying to do?
Well, I just did like 1 plus 10 times 10 divided by 2 plus 1 plus 9 times 9
Okay,
divided
so
by 2.
the first part is here, and then the next part is this one. So that will be 1 plus 10 times 10 divided by 2.
Yes.
Right? You add them together is 10 squared.
Yes.
Cool. That's cool. Right? Another thing is when we do 1 all the way to 100, well, there is an equation there. So no matter it's 100, let's do 1 all the way to n. So this one is, if you just sum them up, is n times n plus 1 divided by 2, right? So there are totally n numbers to add together. They are consecutive numbers. So there is a formula right there. Okay, this is called arithmetic sequence. I think you learned it from algebra, right? So, but the solution I provided earlier on, it doesn't require algebra knowledge. Okay, cool. Let's move on. The second problem, okay? I promised Rakov to talk about the second one, all right? So the second one is, it's also an addition of a bunch of numbers. And these numbers, okay, let me first. Okay, 1 plus 1 divided by 1 plus 2, and then plus 1 divided by 1 plus 2 plus 3. All these are 1 divided by something. At the end, it's 1 divided by 1 plus 2 all the way to 100, okay? So Rakov, can you share with us what you did?
What I did was I kept on adding all of the numbers, and then I formed a pattern, and then I used that pattern to find the last number.
Okay, so please explain to us how you form them and how you find the pattern.
So I wrote 1 as 1 over 1.
Okay, 1 over 1.
And then 1 over 1 plus 2 is 1/3. So if you add 1/3, it makes 4/3.
You add 1/3. Okay, so that's 4/3.
Yeah.
So if you add the first two, you get this one, right?
Yeah.
Okay.
And then if you add that to 1/6, you get 3 halves.
You add 1/6, you get 3 halves.
Yes.
Okay.
And then when you add 1/10,
okay,
you get 5/3. I mean, sorry, not 5/3. 8/5.
Okay.
And then the next one is 5/3.
Okay.
So the pattern that I saw was that if you add the odd numerators, like the 1 plus 3, you'll get 4, which is in the middle.
Hold on. So 1 plus 3 is for here. This one here.
Yeah.
Okay.
If you add the numerator from the first and the numerator from the third, it gets the numerator in the second. And then it keeps on going like that. If you add the numerator in the third to the numerator in the fifth, it gets the numerator in the fourth.
Third and fifth. Where's the third?
So 3 plus 5 will get 8.
3 plus 5 is 8. Okay.
Yeah. And then the second thing that I noticed was that all the even numerators are multiples of 4.
Even enumerators are multiple of 4. Even enumerators are multiple. Okay, yeah, it is.
So what I figured out is that the second one is the first multiple of 4.
Okay. Oh.
The fourth one is the second multiple of 4.
Okay, cool.
So that means the 100th one is the 50th multiple of 4.
Nice.
So that means it's 200 is the numerator.
Okay.
And the fraction cannot go over 2. So it is the number directly less than 2. So it'll be 200 over 101.
Yeah, 200 over 101, right? Wow, that's smart. Okay. Well, along your line, I also observed this. I mean, this is a method I didn't think of, right? So I also observed this. Look at this. So you wrote the second one, 1 plus 1/3 is 4/3, right? And then the next one, you do 3 halves. Look at 3 halves. This is also 6 divided by 4, right? And look at this 5/3. This is also 10 divided by 6, right? So if you look at this 4, 6, 8, 10, this is the top, right? The bottom is 3, 4, 5, 6, right? So following this, we can get the last one will be 200 divided by 101, right? Just along your line. Cool. Very good. Very good. Any other ways of solving this? I see Leo raising your hand. Okay, Leo, why don't you talk about yours?
Well, I first said that it was basically 1/1
Okay.
plus 1/3 plus 1/6
Uh-huh.
plus 1/10 plus 1/15 and so on.
Uh-huh.
And then I kept the 1/1 on the side.
Okay. So you okay?
And I saw that the denominators of 1/3 and 1/6 were both multiples of 3. So
Denominator of 1/3 and 1/6, they are both multiples of 3, okay?
So I multiplied them by 3.
Okay. So
I got 1/1 plus 1/2.
so then you do 1/1 plus 1/2 like this.
Yeah.
Okay.
And then I saw that 1/10 and 1/15.
Uh-huh.
They were the denominators were multiples of 5. So
Okay.
it equaled
1/5
times
1/2 plus 1/3.
And then I saw for 1/21, it could be 1/7
Okay.
multiplied by 1/3 plus 1/4.
Okay.
And then I saw that the next one would be 1/9 multiplied by something, and then 1/11 multiplied by something. And I saw for the numbers inside of the parentheses, so the denominators would be 1, 2, 2, 3, 3, 4, 4, 5, 5,
Uh-huh.
6, and so on.
Uh-huh.
So then I saw that the last one would be 1/99 multiplied by 1/49 plus 1/50, and I had
Hold on, slow down. The last one, what's the last one?
1/99 multiplied by 1/49 plus 1/50.
1/99 times 1/49 plus 1/50.
And then I saw there would be a 1/5050 left over.
Okay, there's a leftover. Okay.
And then when I multiplied them out,
Uh-huh.
I got
Hold on, there's one thing. So you have 1/1 plus 1/2. This is 3 divided by 1 times 2, right?
Yeah.
And then the 3 and 3 canceled out.
Yeah.
Okay. So basically you have 1/1 plus 1 times 2, 1/1 times 2 plus 1/2 times 3 plus plus 1/49 times 50 plus 1/50, correct?
Yeah.
All right. So then what's the next?
So then I kept the 1/1,
Uh-huh.
and then I saw that any two fractions that their denominators were consecutive, then the product of the fractions would equal the difference.
Oh, okay. So you find this 1/1 times 2 equals 1/1 minus 1/2, right?
Yeah, and then I saw 1/2 times 3 equals 1/2 minus 1/3.
Okay.
And I kept going, and I saw that the 2's and the 3's and all those would cancel out.
Okay, you cancel these, and then 1/3 minus 1/4. You cancel all these until the last one, right? So you have 1 in the beginning and 1/50 at the end.
And then I found that I was left with a 1/1 and another 1/1.
Okay, so that will be 2
and then
minus 1 divided by 50 plus 1/50, right?
Yeah.
Oh.
And then I added and I calculated all of those.
Okay.
I got 200 over 1/1.
All right, good. So this is another way of solving this. Good. So this will take some time, but this is a good thought. All right. Any other ways of solving this? Let me look at the chat box. Okay. Who else? Well, there's someone spamming the chat box again. All right. Akash. Who else? Who had other ways of solving this? If no, I will talk about another way. Kyle. Okay, Kyle, please unmute yourself and introduce another way of solving this problem.
So you can, it's kind of like Leo's. It's just like for that. So I figured that n1 over n minus 1 over n plus 1 equals 1 over n times n plus 1.
Mm-hmm. Okay.
And in our problem, in this problem, it's 2 times 1 over n times n plus 1.
Oh, so you said this problem is 2 times, well, basically 2 divided by n times n plus 1, right? Something like this?
So it's also, so it's also 2 times n 1 over n minus 1 over n plus 1.
Okay, so this is, but first let me ask you, how did you get this? How did you get this 2 over n times n plus 1?
I think my dad just taught me.
Oh, your dad taught you, okay. So let me go over this, all right? So if you have a number 1 over 1 plus 2 plus 3, plus n, right? So this is just one of those things we were adding together, right? One of those fractions. Look at this, look at the bottom, look at the bottom. 1 plus 2 plus n. I just introduced you something, right? So when you add them up, this is equal to n times n plus 1 divided by 2, right? So that's the bottom part. Then what we are getting for each of those fractions is 1 over n times n plus 1 over 2, right? So this is the same as 2 over n times n plus 1, right?
Mm-hmm.
So this is the same as 2 times 1 over n minus 1 over n plus 1, right?
Mm-hmm.
Now we have those numbers, 1 plus 1 divided by 1 plus 2 plus 1 divided by 1 plus 2 plus 3 plus plus 1 divided by 1 plus 2 plus 100, right?
Mm-hmm.
So
like,
yeah, keep going.
So like it's pretty much the same thing as Leo, just a little different. It's 1 over n minus 1 over n plus 1. There's, for the positive side, there's 1 over 1, 1 over 2, 1 over
All
3,
right,
way to 1 over 100. And on the negative side, it's 1 over 2 all the way to 1 over 101.
all right, so let me write it down. So you have 1 plus, so this is 1 over 1 plus 2 is the same as 2 times, 2 over 2 times 3, right? So, and then plus this one is the same as 2 divided by 3 times 4, right?
Actually, I'm going to multiply the 2 at the very end.
Yeah, so we'll take out the 2. Okay, so let's look at each fraction first. This is 2 divided by 100 times 101, right?
Mm-hmm.
And then if you take out all these 2's, okay, take out these 2's, it becomes 1 plus 2 times 1 divided by 2 times 3 plus 1 divided by 3 times 4 plus plus 1 divided by 100 times 101, right?
Mm-hmm.
And then this one, 2 times 3, this is 1/2 minus 1/3 plus 1/3 minus 1/4, right? So this is canceling out, plus 1 over 100 minus 1 over 101, right?
Mm-hmm.
So then we're getting 1 plus 2 times 1 over 2 minus 1 over 101, right?
Mm-hmm.
So this is the same as 2 minus 2 over 101. This is 200 over 101. Cool.
Mm-hmm.
All right. Any other ways of solving this? I see Olivia saying you can use induction. Olivia, can you unmute yourself and talk about it?
So I said x of n would be the denominators of all the fractions.
Okay.
And then, no, I mean s of n.
S of n, oh, S of n,
Yeah.
okay.
So that equals n times n plus 1 over 2. And then I made x of n the whole fraction, so it would be 1 over s of n. Which is 2 over n times n plus 1. So then if I solve for x of n plus x of n plus 1.
S of n, like this?
X of n.
Keep going.
I meant x of n plus x of n plus 1.
Oh, like this? Oh, x, okay, sorry. X of n plus x of n plus 1, okay?
That equals 2 over n times n plus 1 plus 2 over the product n plus 1 times n plus 2. So then you can factor out a 2 from that and then make them have a common denominator, which equals 2 times n plus 2 plus n over n times n plus 1 times n plus 2.
Okay. Is what I'm doing here correct?
N plus 2 plus n.
Oh yeah, plus n, yeah.
So that means the numerator is 2n plus 2, and then the denominator is n times n plus 1 times n plus 2. So then you can factor out a 2 from that, and then you get 4 times 1 over n times n plus 2.
Like this?
Yes, which means the numerator is just 2 times 2.
Okay.
And then if you solve for x of n plus x of n plus 1 plus x of n plus 2, that's the quantity 2 times 2 over n times n plus 2, and then plus 2 over n plus 2 times n plus 3.
Equals what?
So then that means you can factor out another 2 from that. And you get 2 over n times n plus 2 plus 1 over n plus 2 times n plus 3.
Oh, that's sorry. I think for the interest of time, we can't finish this. We cannot finish this induction. We have only 10 minutes left. Okay, sorry. Olivia, sorry, we don't have enough time to finish this, but I think this is a good thought. So I will leave the class to finish this afterwards. All right. We have to go over the third problem. Okay. All right. So the next one. Our spotlight student, please talk about this. We have about 5 minutes left.
Okay, so the first thing I did was just I just drew the parallelogram that I described.
Okay, so, draw it. Right, so drawing this is not easy. Okay, drawing this is not easy. So I will draw this for you. All right. So for the interest of time, so you said first we have this A, B, C, D.
Yeah.
I will do A, B, C, D. Is this okay?
Yeah.
And then we'll do E, F. Because I didn't say E, F, G, where whether they're in the middle or not, right?
Oh, I had B in the bottom left corner, so I just had B in D switched places.
Oh, okay. So you have B and D switch places. Okay, that's fine.
Yeah.
We'll do this. A, B, C, D.
Yeah.
And then you have E here, F here, and G here. Is this okay?
Yeah.
All right. So then it said AF, connecting AF. We'll put F here, right? AF and EG, and then we have BG, okay, and what? And DE, like this. This is okay?
Yeah. Yep.
All right. So tell me what these numbers are, because I don't have the problem in front of me. So what's ED and AF? What's the interaction here? Intersection?
ED and AF.
ED.
Oh.
That's H.
ED and AF is H. Yeah.
Okay. And then HI. I.
Yeah.
AF and EG is I. And then AF and BG is J.
Yeah.
AF and BG is J. So here is J, right? And then we have DF and BG. DF. So I connect DF as well. DF, BG is
K.
K. And then this one is L, right?
Yep.
Okay, good. So we have this, we know which one is 36?
36 is the
EI,
EBIF, EBIJ.
BEIJ,
So,
this is 36.
Yeah.
Okay. And this little triangle is 4, right?
Yep.
And then EHI here. No, not EHI, sorry. LKG. LKG is 4, yeah.
Yeah.
And then KJF is 5. This is 5.
Yeah.
EHIL, this is 40. Okay? Yeah. Now tell us what you did.
Okay, so what I did first is just so since you find the area of a parallelogram by doing height times length, and these are all triangles. Finding the area of a triangle is the same thing, except you just divide by 2 at the end. So I set up an equation which was DEG plus GBC
plus
GBC.
GBC, okay.
Yeah. Equals DAE plus GEB.
Plus GEB.
And I also did a second equation, which was
So this is basically half of that parallelogram.
Yeah.
Right? Good. All right.
And I did a second equation, which which was also equal to half, but I did it with AFD.
AFD
Equals ABF.
ABF
Plus DFC.
plus DFC. Good.
Yeah.
And this is also half of this parallelogram, right?
Yeah.
Good.
So after that, I just labeled all the different triangles with S1, S2, and so on. So
Right.
I started with the ones on the top left, counting down. So I just made S1, S2, S3, and S4 the left side, and then I just kept going.
Okay.
So
you label each area and then add them up, and then finally you find this this number, the AEH, right?
Yeah.
Okay. So good. So this is basically, this problem doesn't need any knowledge of similarity, similar triangles or a Pythagorean theorem or any of those complicated stuff, right? All we need to know is within this parallelogram, if we come up with a triangle sharing the same base as one side of the parallelogram, this triangle is half of the area of the triangle is half of the parallelogram, right? And then we can do the same, if we have two, if we have two triangles, the sum of the base of these two triangles is the same as one side of the parallelogram, then the sum of the area of these two triangles is half of the parallelogram's area, right? So we can look at this, right? So we have one triangle here. Well, first of all, there is a half of the parallelogram, ADF. This is one, AFD or ADF. It's the same as this piece, BEG, right? BEG is one of them. BE plus AED, right? Okay. So we have these parallel, as long as you find these halves, like what Ryan did, or what I'm doing here. Find these halves, and then finally you will find out, 36 plus 4 plus that specific triangle equals 40 plus 5. And then that triangle, FJK, or no, not FJK, it's asking AEF, AEH is 5. So the answer to this is 5. Again, because of due to the time limit, we can't go into too much detail of this. But as long as you know, for this specific problem, all you need to know is finding the half of the parallelogram. Then you have the answer. Okay. The answer is 5. I think that's about it. Any other questions? So some of you did very good job on this. I'm not saying you did it right. If you make this do this question correctly, that's great. Some of you think about this for a long time. That's good. I'd like you to do that, right? So you have another homework coming out next week. All right, guys. I'll see you next week.
Thank you.
Thank you.